Okay, so let's do the tutorial question. So question number 1. So actually for question number 1, okay, for 1 Roman and 2 Roman, we have covered for the last topic, which is when we discuss about open circuit test and short circuit test. So we just use this answer to answer the next question number 3 Roman and 4 Roman. Okay, so based on previous answer, the parameter that we get, this is refer to secondary side. Refer to secondary side. Because of on the 2 Roman, the question asks to determine the various parameter that refer to low voltage side of the transformer, which is when we look at the voltage level. The low voltage side is 120 volt, which is on the primary side of secondary side of transformer. So this all parameter is referred to the secondary side. So for number 3, we want to determine the voltage regulation of the transformer at 0.5 power factor lagging. So firstly, when we draw the circuit, so remember the circuit is R equivalent S, JX equivalent S, and then so we have VS with angle of 0 degree, and then this is referred to primary and secondary, so this is VP over A, and then this is IS, with the angle of theta, negative theta, because of lagging power factor. R equivalent S, J, X equivalent S. So our purpose is to determine VP over A. And then remember the equation for voltage regulation. VR equals to VS no load minus VS full load divided by VS full load. For this case, VS no load is VP over A, because of we referred to secondary side. And then VS full load is our secondary voltage, which is VS angle of 0 degree equals to 120 volt angle of 0. You can refer at the equation, and then this is also the same value, 120 angle of 0 degree. And then what is IS? IS is secondary current. So based on S equals to IS multiplied by VS. So you can determine IS by S divided by VS, 1000, so given in equation, divided by 120 volt, so you get 8.33 ampere. And then next is from the equation, the given power factor is 0.8 lagging. So based on formula, power factor equals to cos theta. So from here you can get the theta. So theta equals to cos inverse, so you bring on the other side, go cos inverse 0.8, sorry, 0.8. Then you can get negative 36.87. So in negative indicates that lagging power factor. So next we want to determine VP over A. So VP over A is equals to, so you can refer the circuit here. So we have IS angle of theta multiply with R equivalent S plus JX equivalent S, plus with VS angle of 0 degree. Then you can determine, so this is IS VP over A, this one, this is based on circuit. So IS is 8.33, angle of theta is negative 36, negative 36.87, multiply with R equivalent S, which is we refer to secondary side, 0.3125 plus J 1.21, and then VS is 100 plus VS 120 angle of 0 degree. So by using calculator you can calculate VP over A. So the answer for VP over A is 128 angle of 29, 0.29 angle of 2.9 degree. So this is VP over A. So we can determine VR by using this formula or this formula. The same formula. So VR equals to 128.29. Okay, you just take the magnitude 128 over 0.29 minus 120, okay, over 120 multiplied by 100%. Okay, so the answer should be 6.91%. Okay, so this is considered good voltage regulation because it nearest to 0%. Okay, just around 6.91%. Okay, so if I can show the how we draw the the phasor diagram. So firstly, based on this parameter, all these parameter, so we have 100 Vs. This is Vs. Okay, and then this is this is VA Vp over A. Okay, this is Vs 120 with 0 degree. So okay, we start draw Vs. Vs is 120 0 degree. Okay, and then we have Is 8.33 negative 36.87. So this is Is. Angle is negative 36.87. Okay, and then we draw R equivalent S, that similar parallel with Is. Okay, and then we draw Vp over A. So the magnitude for Vp is 128. So for sure, okay, the line is longer than Vs. Vs is 120. So this is 128.29. Okay, and then the angle, okay, the small angle here is 2.9. So 2.9. And then you just sambungkan this one, okay, to determine Jx equivalent S. Okay, so this is represent the diagram, okay, for transformers, right? Okay, so next we move on the efficiency. Okay, determine the efficiency of the transformer at rated condition and 0.8 or factor lagging. Okay, so actually for number 3 and number 4, you can determine, okay, the voltage regulation efficiency either at primary or secondary side. Okay, so because of on the 2 Roman, okay, the parameter is referred to secondary side. So we find number 3 Roman and 4 Roman, okay, voltage regulation and efficiency at secondary side. Okay, so okay, to determine efficiency, okay, remember the general formula is PR over PR plus P loss multiplied by 100%. So actually this is PR plus P loss is equals to P in. Okay, based on power flow diagram. So this is PR, okay, this is P losses, P loss, P loss. Okay, and then this is P in. So PR plus P loss is equals to P in. Okay, so how to determine P out? Okay, P out is Vs Is cos theta. So we know that cos theta given equation is 0.8. Okay, Vs is 120, Is is 8.33. Okay, so we calculate okay, before for Is, and then okay, if we calculate here, P out is 800 watt, and then for P loss, okay, we have PCU. Okay, PCU is because of R equivalent S, and then P core is because of RC. Okay, R core lah. Okay, so for PCU, okay, the equation is Is squared multiplied by R equivalent S. Okay, because of the current that flow through R equivalent S is Is, okay, secondary current. Okay, and then because of we referred at secondary side. Okay, so 8.33 squared multiplied by R equivalent S is 0.3125. So we get this one lah, this is value. And then next is for P core. So P core is Vs, okay, over 480. So 480 is RC S. Okay, RC that refer on secondary side. So you get 50 watt. So and then just input in the okay, write back on the equation. Okay, P out over P out plus total losses multiplied by 100%, and then you get the efficiency. So 93.93%. Okay, so for the next question, I just going through. Okay, you can do it by yourself. Okay, so we have here is so this is S, yeah, apparent power 1500, and then this is primary voltage, this is secondary voltage. Okay, so we can consider that this is stepping up, okay, step up transformer. Okay, because of on the primary side the voltage is low compared to secondary side. Okay, and then this is data for open circuit test. V open circuit, I open circuit, P open circuit. And then this is data for short circuit test. V short circuit, I short circuit, and P short circuit. Okay, so okay, for the first question, okay, determine the equivalent circuit parameters referred to the high voltage side. Okay, we know that high voltage side is on the secondary. Okay, because of when we refer on the voltage level here, okay, the higher voltage is on secondary side. So then the question asks the parameter that refer to secondary. So we know that we have to determine from open circuit test RCS, okay, and then JXMS, okay, and then for short circuit test is R equivalent S and JX equivalent S. Okay, and then for sure you have to test. Okay, for open circuit test you have to test either V open circuit is equal to VP or VS. Okay, and then for short circuit test you have to test I short circuit either equals at I primary or I secondary. Okay, so let's say okay, for V open circuit equals to V primary. Okay, for sure if you compare here, okay, V open circuit is equals to V primary. Okay, so the calculation, okay, you calculate when you get the answer is RCP, okay, at primary side, then you have to refer on secondary side. So remember how to refer on secondary side. So we have Z1, Z2. Okay, when we refer from secondary to primary, we multiply by A squared. When we refer from primary to secondary, we divide by A squared. Okay, so what is A? A equals to VP over VS. Okay, for this case 144 divided by 230 volt. Okay, so okay, for open circuit test, okay, the answer firstly you get on primary side, then you have to refer on secondary side by divide A squared, this one. Okay, so yang ni you have to calculate. Okay, I short circuit is 0.4. Okay, firstly you have to determine the value of IS and IP. So IS is IP is S divided by VP, so equals to 10.4. So we know that I short circuit, okay, when I calculate the IP, S is 1500 divided by 144. So the answer is 10.4 ampere. So IP is equals to I short circuit. So the parameter that you get, which is R equivalent, okay, R equivalent and JX equivalent, is originally at primary side. So you have to refer on secondary side by divide by A squared. Okay, so that is on number 1. Okay, equivalent circuit parameter referred to high voltage side. Okay, and then next is the voltage regulation. Okay, the voltage regulation at 0.899 power factor lagging. Okay, so because of at number 1, okay, the number 1 the parameter is refer high voltage side, so which is at secondary, so we can do the voltage regulation at secondary side. Okay, so firstly you have to determine the IS, I secondary equals to 1500 our VS divided by our S divided by VS. Okay. Okay, 6.52. So VS equals to 230 volt. Okay, so you get 6.52. So mesti ada angle. So angle based on power factor. Okay, given power factor here is power factor equals to 0.866 lag. Okay, so we know that power factor is equals to cos theta. So you can determine theta. Okay, cos inverse 0.866, sorry. Okay, 30 degree. So negative 30 degree lah because of lagging. Okay, so the angle is negative 30 degree. Okay, and then we know that when we refer to secondary side, okay, so this is R equivalent S, JX equivalent S, this is VS, angle of 0 degree, and then this is VP over A. So the current flow is IS based on this one. Okay, R equivalent S based on question number 1, and then this is JX equivalent S. Okay, the parameter that you refer to secondary side. Okay, so we want to determine VP over A. So VP over A equals to IS angle of theta, okay, multiply by R equivalent S plus JX equivalent S, okay, plus dengan VS angle of 0 degree. So you get the answer for VP over A. So voltage regulation, okay, VR equals to, okay, VP over A minus VS divided by VS multiplied by 100%. Okay, so you get the voltage regulation. So next is the full load efficiency at 0.866 power factor lagging. So we know that efficiency equals to, okay, this is symbol for power efficiency, macam ni lah. Okay, efficiency equals to PR over Pin multiplied by 100%. So we know that PR equals to VS IS cos theta. So cos theta is based on 0.866 power factor lagging. Okay, so VS is based on our rated, and IS, okay, based on S divided by VS. Okay, and then Pin equals to PR plus P loss. Okay, total P loss, which is we have PCU and P core. Okay, so PR is similar on this one. So PCU is equals to IS squared multiplied by R equivalent S. Okay, and then P core, okay, equals to VS squared divided by RCS. Okay, and then you get P core. So just insert in equation, multiply by 100%, and then you get the efficiency. So next is number 4. Draw the circuit referred to high voltage side. Okay, which is referred to secondary side lah. Okay, so you just draw. You can refer on the slide also. So this is R equivalent S, JX equivalent S. So this is VS, and then for this one, okay, we have RC, and then JXMS. So this is RCS, and then, okay, this is VP lah, VP over A. This is IS. Okay, this is IS angle theta. Okay, R equivalent S, JX equivalent S. Okay, so this is the circuit, okay, the complete circuit for transformer. Okay, but when during we do voltage regulation, this we neglected, okay, because of the current is too small. So this is we not consider on this branch for voltage regulation, but for overall, okay, this is the complete circuit that refer on secondary side.